Hello, I'm live. So I'm uploading a video right now that is me finishing up coding train challenge number 1 in Rust. Here's what it looks like. It just kind of zooms through space, which is pretty cool looking. So today we're going to move on to number 2. Let's have a look. So there's coding challenge number 1. Number 2 is the major sponge fractal. Unfortunately, that is 3-dimensional. I don't know if I can do that. So if you'd really like to see me do that, maybe leave a comment saying like, or put it in the chat, I guess. This is my first time live streaming, so I don't know. Let's start with number 3 then, because this looks pretty simple. This is the snake game, as it says so aptly. So let's see. We can look at either the P5.js or the processing. I'll have a look at the P5.js this time, just because we looked at processing last time. We might as well mix it up a little bit. Let's see. So we create a canvas. We create a snake object. Oh, this is handy. Thanks, GitHub. We set the frame rate to be 10. I assume that is because we want to limit the number of updates that the snake has to make the game easier. So I'm going to go ahead and make this independent of the frame rate instead of doing that. And we have pick location, which if I remember the video correctly, this sets the food location. Yeah, it does. The food is a global variable, but I'll have to convert that a little bit. Whenever the mouse is pressed, the snake's length gets increased by 1. This is a cheat that he used in order to test things. Then we set the background with 51, 51, 51. We check if the snake eats any food, and if so, we're going to re-roll the food. Snake might die, or we check if it's dead. We update it, we show it. So once again, I'm going to make this independent of the frame rate. Then we draw the food. Then we check the keys. Pretty simple stuff. Like, this is 50 lines of JavaScript. Not too much to get confused by here. We look at the snake. There's some game logic here. I'm not going to go over it for the sake of time. Let's just start implementing it. So we will create a new crate for this. Episode 2? No, 3. Excuse me, we skipped 2. Which I still feel a bit bad about, but 3D graphics is not my forte. Let's build it. Yep. And we're going to kind of, let's see, we'll add a path dependency. Let's first do SDL2. And we'll add a path dependency, or we'll add features, GFX, in an array, please. Then we will add SDL helpers, path equals SDL helpers. There we go. Let's have a look. I'm going to just put this on the left half of the screen. Maybe move that up a little bit. This is my first time doing things live, so bear with me a little bit. Alright, so we're going to create a snake. First up, let's do some initialization stuff, just the typical ritual that's required, and not required in JavaScript, so we are going to be kind of on our own here. We'll say, we're going to throw away the SDL context, throw away the video subsystem. We don't care about that stuff. Maybe in the future we will, but for now, I think it's fine. Save the canvas, and we'll save the event pump. Init SDL. We give it a title, snake. And we give it a width and height. Those are constants. Turns an anyhow result. You know what? Let's not use anyhow. We'll just do some experiments on this particular day. Let's restart Rust Analyzer because it seems like it's not picking up our new crate. Should start seeing some red squiggles here. Come on now. Can I import? Yeah. Cool. Oh, it's frozen. Import SDL error. Is this one? Return OK at the end. And we need an update timer, like I mentioned. So we developed this in the YouTube video. So I created a class called timer. And we're going to set the interval here. We'll just update 60 times or 10 times a second to follow what the guy did here. Maybe we ought to make that a constant too. First, let's do width and height. And we'll call it UPS for updates per second. Update interval is just the inverse of that. Oops. Don't know what kind of code I'm writing here. Timer. Oh, and this is compiling. Sweet. Let's do the main loop. For event in event pump.pull iter. Event is quit, which is this is the event extension trait that I added in the library. We're going to break the main loop. And we will say, we'll check the timer. So if we're about to do a tick, we'll say snake.update. And I will uncomment that later, whenever we actually have a snake. First, I want to make sure this works. Canvas.clear with, or no, it's not clear with, it's background. Color, RGB, 51, 51, 51. Just like Daniel Schiffman did. Canvas.present. So this should run. What's wrong? Oh, forgot a semicolon. Classic. Run. There we go. You can see we got a gray background, and it's called Snake. And it's 600 by 600. Note that it's not resizable. For most of these coding train projects, the window is not resizable, and it's hard-coded. Maybe it could be a cool exercise to do that in the future to allow resizing. But it involves there's a lot of math involved there, especially for a grid-based game like Snake. So for now, we're just going to leave it. Alright, so let's start creating the Snake class. Oh, and I forgot. This should be update interval. Might as well use our constants, right? So we have a struct snake. You can see that it has a lot of properties here. X. You know what? Instead of X and Y, we'll make a pos vector. And we have a speed. Call that vel for velocity. Then we have total, which I believe is the number of units in its tail. So really, I'm not sure why we have this. Where's total used? I'm not really sure why. So For now, we'll just say tail is a vector of what? Of vectors. That's a bit weird. We'll create a constructor. Position is a vector at 0. Velocity is positive in the x direction and 0 in the y direction. The tail is an empty vector. We'll just use the vec macro there. Then we have this dot eat equals function of position. So position looks like it's a vector here because it's got pos.x, pos.y. So we will say pos is a something that implements asref vector 2. And does it return anything? It returns a bool. So we will say let d equals this dot or self dot pos. Oh, we need self dot distance, and we'll write this in a moment. Pos dot asref. Let's go write that dist function real quick. That'll go in the vector. Take self and other. And it returns a float. Self.x times, or no, let's do dx. Self is other.x asref.x minus self.x dy other asref.y self.y. And we will return dx times dx plus dy times dy, the square root of that. And that should never panic because it's always going to be a positive number or 0. There we go. That looks done to me. And it looks like it compiles here. Let's see now. If d is less than 1, we add to the total, which means if we're on top of the fruit, I suppose. So this is taking the fruit position, or food, I guess. We should call it food pos. If d is less than 1, self.total plus equals 1. I understand why we're doing this now with total. The dance with total is because we don't want to push to the vector immediately, but we want to say, hey, I need to push to the vector soon. We'll just return d less than 1 here, instead of doing the true else false sort of thing. This has to be, this is a mutable reference. There we go. It looks like we're done there with eat. And then we have a function called dir, which sets the speed. So the velocity is always going to be along an axis. But we don't really care about that. We'll make it simpler by not requiring the user to construct a vector. Self.vel.x equals sx. Self.vel.y is sy. Then we have a function called deth. What is that? Sorry about that. We have a function called death thing that says if we are eating our own tail, then we start over. I'm gonna get rid of the console.log. Well, maybe I'll keep it. Why not? Yeah, possibly her, right? Doesn't return anything. So we will say for each segment in the tail, which is a vector 2, let d is the distance from self.pos to segment. If d is less than 1, then we are eating ourselves. Print line, starting over. Just going to copy the functionality here. Self.tail equal .clear. Let's be a little bit optimal here. What's wrong? Cannot borrow self.tail is mutable because it is also borrowed as immutable. Good point. We'll say lost equals true, and then at the end of the loop, if lost, self.tail.clear. That's much better. And the reason for that is we can't delete the vector while we're iterating through it. That sounds like a recipe for a bad time. It probably is fine in JavaScript, but it's definitely not okay in Rust. Oh, and it looks like my other YouTube video is uploaded. That's good. One sec, guys. Sorry about that, just shilling myself a little bit. Alright, let's continue on. We just have update and show left to write. This is going well. We say this.update equals function, and it doesn't return anything, but it does mutate itself, so that's important. We will write it like that. So we will say we're going to shift the tail backwards or forwards, I can't tell. In this case, we need to be iterating mutably and enumerating. That sounds right, because we're going to be copying from the i+1 position into the I position. For segment, or I comma segment, in self.tail.itermute. Self or segment equals self.tail I+1. And I have a feeling this is not going to work. What's this? Oh, we have to enumerate, right? And the reason this is not going to work is not because of that, but because it is borrowed as mutable already. We can't borrow it as immutable at the same time. So what we got to do is just say screw the for each loop. We're going to go from 0 to the length of the tail minus 1. Self.tail I equals self.tail I plus 1 dot clone. Vector2 does not implement clone. Well then, let's go ahead and write that. By write it, I mean derive it. There we go. So we are now copying properly. And the reason this works and the for each loop didn't work is because we are only borrowing for this microsecond here. And when we get to the for statement again, we are no longer borrowing self.tail. Hopefully that makes sense to you guys. If self.total is greater than 0, let's make that a little cleaner. Self.tail. Now, I don't ever see him pushing to this vector. So that's a problem. I don't see any instance of him pushing. So when do we push? We push when the total has increased. So if we say if self.total is greater than self.tail.len, then we're pushing. The pause. Otherwise, self.tail self.total minus 1 equals self.pause.clone. That seems to work. Now we're going to add the speed. We have this scale value. What's scale? Scale's 20. Oh, okay. I think what scale is that it's the pixel position or the number of pixels per square. I think that's what that is. We have this constrain function that I'm going to have to get to later. Self.pause.x is equal to itself plus self.vel.x times scale. We're going to repeat that for y. There we go. We need this scale constant. And it's 20. Might as well copy what he's doing. We need to import it here. All right. I believe it's clamp. No, we have to, because clamp is not stable yet. Unfortunately, we have to do this kind of manually. Gotta use floating point literals. And repeat for y. There we go. Oh, gotta import height. I usually remember to do that, but not always. Please tell me that this does not mutate it. It looks like it doesn't. canvas. And this can have an STL error. Canvas dot set draw color white. Import that. Let's return OK at the end of the function. So we say for I equals 0, I less than tail length, I plus plus. So actually what that means is for each segment and tail. Dot iter. You know what, let's write the proper function that handles the matrices. Well, I actually don't know how to do that. Because consider the case where the rectangle is not axis aligned, where the rectangle is rotated by some angle theta. I don't exactly know how to do that right now. And I don't know if I care enough to try right now. So we'll just say canvas.draw or fill rect self.tail, or sorry, segment dot x as, or wait, so we need to construct a rect self or segment dot x as I32, segment dot y as I32, scale as U32, and scale as U32. Map the error. One of the downsides of not using our custom function. But we can't write our custom function right now just because I don't know how. Canvas.fill rect new, self.pos.x, pos.y. There we go. That's the snake done. Let's go back to main here, main.js or sketch.js. And let's figure out how this works. We have setup. We create a snake. Let's do that. Now it's going to have to be mutable. Here we go. We got a snake. So if the timer ticks, snake.update, snake.show, let's see, we got to handle key presses. And we got to do some kind of ugly pattern matching here. Match key code. Key code. Instead of arrow keys, we're going to use WASD because we're gamers. We're gaming. That's annoying. I'm doing that wrong. Anything else, we ignore it. Import key code. Alright, looks like we're handling key codes. Let's run this to see what happens. And we crash. Attempt to subtract with overflow. Line 59 in snake. That's no good. Ah, length is 0. We only care about this if self.tail.length is greater than 0. Right? Or, yeah, more concisely is empty, but not that. Okay, we got a little snake. And he's able to move around. Now, let's add the cheat where if you click mouse 1, he gets longer. Because I want to see if that works. So it just hooks in directly to s.total. If let event mouse button down event snake.cheat. There we go. That's a cheat function. Now if we click the mouse, it gets longer. And hey, that actually seems to be working. And what happens if I die? Like if I get so long. Okay, death is not working. I don't think we actually called the death function, so that's probably why. But okay, we got a snake. That's the most important part. Oh, let's make sure you can't go off the edge. Can't go off the edge there. Can't go below 0. Can't go above 0. Cool. So we got a cheat code in there. Let's see. Pick location. So we got to do some food stuff. I'll make it a struct with a method instead of this weird vector thing. Struct food pause vector 2. Initially, so let's make sure we're doing this right. We have calls and we have rows. Takes the floor of that and multiplies by scale. Okay. Let's actually make this a new type. This is a new type. Just like that. Floor it times scale. And then the same thing. So we need the rand crate for randomness. Should look correct. We need to import the RNG trait. Floor. What's wrong with floor? Can't call floor on ambiguous numeric type float. Well, let's make it not ambiguous by defining calls and rows. Is width over scale. Is height over scale. Now it looks like it works. So we will say let mute food is food new. So now that's going to pick a random location for it. We're gonna add a show function to food, just to make this a little bit more object-oriented. Because here he's doing a data-oriented thing where the food is just a vector. But I want to write some object-oriented code, so let's do it. Set the draw color to, I guess we'll just copy the one that he has here. Canvas.fillRect self.0.x as I32, y as I32, scale, scale. Wrong. Expected one argument found 4, because we have to construct the rect. And then we have to map the error. There we go. That's the show function. So we will say food.show canvas. And then if the snake eats the food, which is in the update function here, so it happens before we update. Is that correct? Reference. Yeah, that's why. Food equals food new. Seems to work. Snake dot check for death. And there we go. I think we're actually done here. We got food. We eat it, we get longer. If we die, then we reset. And it says starting over in the console, just because. And if we double back on ourselves like that by accidentally hitting left and then right, then we also start over. I could make it so that you are not allowed to do that. But I don't know. I think this is good. What happens if we stand still? Okay, we also get reset. That's good. But yeah, that's Snake written in Rust. Pretty much one-to-one translated from processing. I mean, we added a little object-oriented stuff there for the food. But other than that, this is a pretty direct translation, I'd say. Oops. Alright, that's enough. What's my warning here? I have an import that's unused. Don't need any of that. We've got some warnings in here too, actually. More unused imports. Now we're clean. Oh, you can see that I had a performance issue here that I wanted to analyze. It turned out the only performance issue was drawing the lines anti-aliased. So here I said ext draw line, but before I said AA line, which is an anti-alias line, and that apparently has a huge performance impact, at least with the SDLGFX library. So recommendation is to not use that. Alright, but I think I'm gonna kind of end the stream here. It's getting late where I am. Thanks for anyone that tuned in. This is my first try doing something like this.